Okay, so the consensus is maybe those last three. So number 19 starts with a circle, and you are asked to perform the following transformation on this circle. You take each ordered pair x, y, and you take one away from the x coordinate. And where am I? 19. Add 2 to the y coordinates. So can anybody tell me what effect that will have on the circle if I add 1 to all of the x coordinates on all of these infinitely many little points here, and add 2 to all of the y coordinates? What's that going to do?
Over the y-axis.
Why would you say that?
Because the y is 2. The x is 3.
So you think it has something to do with the x and the y axis? Okay.
I would think so.
You would think so? Anybody want to build on that or argue with that? Or can you? Let's find out. Let's see if Nate is correct. Can you tell me at least one point on that circle that I can test this with? 0, 2.
I mean 2, 0. Sorry.
2, 0 is right there.
Yeah.
That's not on the circle.
Yeah, this
If I want to point on the circle.
2,
2, 2. Okay, so let's take that point right there, which has the coordinates 2, 2. If I subtract 1 from the x coordinate and add 2 to the y coordinate, what will my new x and y coordinates be? 1, 4. So I'm going to go over 1 and up 4. Okay? But that's only 1 point. We're going to need more points than that to see what the heck's going on. So give me 2, 2. Point on the circle.
How about 0, 0?
0, 0. That'll work. This guy right here. So if I subtract 1 from the x and then add 2, where's that going to do? Negative 1, 2. Somebody shouted out already. So these points here are my new points. What? What's another one? There's a couple more easy ones.
4, 0.
4, 0. If I subtract 1 from the x coordinate and add 2 to the y coordinate, what does that do? 3, 2. So that new point is right here. And 2, negative 2, this guy down here. If I subtract 1 and add 2, then that puts me on 1, 0, right there. So how would you describe, using English words, not math words, what's happening to each one of those points? Where are they? How are they sliding? Which direction and how far? Up and to the left. How far up? 2, and how far to the left? 1. So every single one of those points has been slid up and to the left. And so if I take this whole circle and slide it up and to the left, does that circle end up on those new points? Yes. So the first answer, the first question was, will you still have a circle? And the answer is yes. The second question is our new circle congruent to our old circle?
Yes.
Yes, because all we did was slide it up and to the left. So in that case, yes and yes. All right? Okay, now let's play again with number 20. So we are once again going to start with a circle. This time the circle is in a different spot. Okay, and now our transformation is different also. We're going to take the x and y coordinates and double them both. So once again, give me a nice easy point on the circle that we could use. 0, 3. So if I take the point 0, 3 and double both of the coordinates, what's my new coordinate going to be?
0,
0, 6. So that'll be this new point up here. Okay. Give me another point on the circle that I can easily work with.
0, negative
0, negative 3. If I double, okay, that's not 0, negative 3.
That's not 0, negative 3.
If I double both of those coordinates, where am I going to end up now? 0, -6. All right, so there's 2 points. Give me a couple more.
3, 0.
3, 0, this guy right here. If I double both of those coordinates, where do I end up?
Right there.
Right here at 6, 0, and then you should be able to see that -3, 0 will get doubled to -6. Can I make a circle out of those new points? Yes? I draw a circle right here.
They share the same center.
Yeah, they share the same center. What are circles that share the same center called?
Centroidal.
Wow.
Kind of close. It's got centric in there. Concentric circles, okay? So these are concentric circles. So the first part of the question is your new shape a circle?
Yes.
Yes. The second question is the new circle congruent to the old circle? No, same shape, different size. So that is a no.
I didn't do that.
Okay? All right, and then let's try one more. So on 21, we are starting with a circle again. And this one is up in the corner there, so we are starting here and going down there. All right, and now my transformation is to take the x and the y, and we are going to double all of the x's and keep the y's the same. So give me a couple points. I mean, the points that you guys have been naming are these points that are on the kind of the four. I don't know what you would call that. Not necessarily, it's not the corners, but the, you know, the north, south, east, west points of the circle. So where would this point go if I doubled the x and kept the y the same? Exact same place, because 0 doubled is still 0, and the y stays the same. Where does this point go? Goes to 8, 0, because 4 doubled is 8, and the y coordinate stays the same. How about this guy? 8, 8, because 4 doubled is 8, and the y coordinate stays the same. And then this last one is a little bit tricky. I don't really have room for it.
16.
Right, this will go to 16, 4, so it'll be out here somewhere. Okay? Is my new shape a circle? No. Is it congruent to the old one? No. Is it a kite? No, because it's going to be round, right? Yeah, so it's some sort of a oval shape
Straight line.
thingy like that. Something like that. Okay? All right, any other questions from that one?
Oh, sir.
Those were the ones? Okay, I'm going to ask you to exchange